Hello everyone. In this video, I will talk about two methods that we use to solve first ODE. The first one is the homogeneous differential equation, and the second one is the binary equation. In this video is the last method that we learn the techniques that we use to solve first ODE. Okay, let's start with the first one, homogeneous differential equation. In this method, you have to know what's the meaning of homogeneous differential equation first. Okay, when you look at a function of first ODE and look at the sentence, every single form in the equation has the same degree. Okay, it's meaning when you look or you find the summation of the power of each single form, they are equal. Like for example, if we have a function of f x y, a function of containing x and y, and see each term, and then you find the summation of each term. Okay, and if they have the same degree, then they are homogeneous equation. Okay, let's look at this example. We have 2x to the fourth minus x to the third times y. And now you find the summation of the power of each single term. Okay, this is power of 4, and the summation here is 3 part 1, so 4. So in this equation, it has degree of 4, so this is a homogeneous equation. Now go to the second example. We have e to the y over 2x plus tan of 3y over x. Okay, just look at this x and y function. So y is the power of 1, x is minus 1. So summation of in this form is 0, and tan 3y over x is minus 1, y is plus 1, so the summation is 0 also. So in this function, it has degree of 1 in every single term. Okay, so this is also homogeneous equation. And here, the third example, we have x squared plus y squared. The summation in each term is 2, right? This is 2, this is also 2, so degree of 2. This is a homogeneous equation. So in the case, if you have homogeneous equation, you can call like m x y plus n function of x y times y prime equal to 0 as a homogeneous differential equation. But you have to check if mx and ny they are homogeneous equation first by find the summation of power of each second term of each single term. Then if we have homogeneous equation, then we can write this function into this form, which is dy over dx equal to a function of y over x, or dy over x equal to a function of y over x. It's the same actually. It's y over x or x over y. It doesn't matter which way you're gonna write. Okay. Then how we gonna solve this method? Go to the next slide. Now let's look at the step to find the solution when we have homogeneous equation. You have to follow this 4 steps. When we have homogeneous equation, then you follow this. Okay. In the first step, you rewrite the equation to form the function of y over x or x over y. Transform that first ODE into this function y over x or x over y. Then you let v equal to y over x, or transform to y equal to vx, and then you do the differentiation of y over dx, then you're gonna get dy over dx equal to v plus x dv over dx, right? The multiplication product. Then after you do the differentiation of v term, then substitute y over x with v, in the first step, and substitute dy over dx with v plus x dv over dx into the first step. After you plug in, then use separation method to solve the problem, which is the most easy one, right? So whenever you have homogeneous equation, just follow this 4 step, okay? Now look at examples of homogeneous equation. So let's take a look at this one, which is x squared minus 3y squared in this parenthesis times dx plus 2xy dy equal to 0. So then if you want to use other methods, you can try, but in this case we want to use homogeneous equation. So if you want to use homogeneous equation, then you have to check if every single terms has the same degree, right? So this is 2, and x which 1, y is 1, so summation is 2, so every single form here is a degree of 2. So this is example of homogeneous equation. So in the first step, you rewrite this function into dy over dx, just transform this. So from the problem here, then we can get dy over dx equal to minus x squared, move to the other side, plus 3y squared over 2xy. Then we can reduce the form into 3y squared over 2xy minus x squared over 2xy. Then we can get in this form, which is 3 over 2 times y over x minus 1 over 2 times x over y. Okay, now this is the first step. Okay, then this is the second step, which is you let v equal to y over x. So dy over x can equal to v plus x dv over dx. Then you substitute v and dy over x into here. Then you can get v plus x dv over dx equal to 3 over 2 times v, right? Because y over x minus 1 over 2 times, this is x over y, so it's gonna be 1 over v. So just the opposite. Okay. Then after you plug in, you use the separation method. Just separate v to one side and x to one side. Okay. And then just rearrange it. Here we get 2v over v squared minus 1 times dv and dx over x. So do the integration. Then we get in integration here we get v squared minus 1. In this side we get ln x, and this is also ln. So in the final answer, not the final yet, in this form we can reduce the form into, get rid of ln. We get v squared minus 1 equal to cx. And in the final step, after you get this form, you have to plug in back the v here, which is y over x square minus 1 and cx. This is the final answer. Okay, not so difficult, right? In this slide, I will talk about the binary equation that we can use to solve first ODE. Okay, first you have to know what's binary equation first. But the binary equation form or the binary equation. So when you look at the first ODE, if you see a function like this, y prime plus px, p is function of x times y equal to gx times y to the n. In this form, we can call it binary equation or binary differential equation. Okay, the important form here is y to the n should be starting from 2, 3 until to the n. Okay, if n equal to 0 or n equal to 1, it's going to be the linear equation form of the first order. Okay, let's look at example. Here we have y prime plus y equal to x times y to the third. N in this case is equal to 3. So this is a binary equation. And the second one is y prime plus y over 2x equal to x over y to the third. In this case, n equal to minus 3. So this is also binary equation. Okay, so then after we have a binary equation of first order, first ODE, you follow these 3 steps to solve the problem. Okay, in the first step, you multiply y to the minus n to the equation. After you transform the problem into this form, then multiply y to the minus n to the equation. In the second step, you let v equal to y to the y to the 1 minus n, and if you do the differentiation, you're going to get dv over dx equal to 1 minus n times y to the minus n times dy over dx, right? So then you use v here and dv over dx and substitute back into the first step. Okay, then in the third step, you use the linear equation to solve the problem. Okay, if you don't remember what the linear equation is, go back to the previous video that we talk about the linear equation method. Okay, now let's look at example of binary equation. Here we have y prime plus y equal to x to the third. Okay, then if you want to use a binary equation method to solve the problem, just follow this. Okay, we have 3 steps, right, from the previous slide. So in the first step, you multiply y to the minus 3 into this problem. This is the first step, right? So we're going to get y minus 3 times y prime plus y minus 2 in this one equal to x, right? So in the second step, you let v equal to y minus 2, y to the minus 2, and you do the differentiation dv over dx of this y minus 2, then you're going to get minus 2 times y to the minus 3 dy over dx. Then substitute v here and dv over dx back into this problem. Okay, we have dv over dx, which is you have to rearrange this form. You're going to get dy over dx equal to in this one, which is minus 1 over 2 y to the third dv over dx. just rearrange this form. Okay, try it. And then after you plug in, you get minus 1 over 2 dv over dx plus v, this one, equal to x. This one is from we transform this form. Okay, this is the linear equation form, so then we can use the linear method to solve it. So the px is minus 2 here, so find the integrating factor, which is u or mu equal to e to the integration of minus 2 equal to e to the minus 2x. So the integrating factor is e to the minus 2x. Then use the integrating factor multiply back into the problem. This one, you're gonna get e to the minus 2x dv over dx minus 2v e to the minus 2x equal to minus 2x e to the minus 2x. So we have made 2 here because we use 2 times every term. So get 2 here and 2 here, and 1 over 2 here is gone, right? So then you look for the combination from here. You're gonna get d e to the minus 2x v, right? So this is the product from e to the minus 2x v, and on this right hand side is minus 2x e to the minus 2x. You can rearrange it, rearrange this one, get minus 2 integration of x e to the minus 2x dx. In this form, you have to use a bypass method to solve it. If you don't know how to do it, you have to ask someone, or you have to review yourself when you study when you are undergrad. This one is the basic one that you have learned before. Okay, so after you do the bypass on the right hand side, you're gonna get this one, minus x e to the minus 2x over 2 minus e to the minus 2x over 4. Then you times minus 2 into the parentheses. Okay, you get x times e to the minus 2x plus e to the minus 2x over 2 plus c. And rearrange the form again until the end. We get v equal to 1 over 2 times 2x plus 1 plus c times e to the minus 2x. And don't forget, in the final step, you have to plug in back what you make assumption from the beginning, which is v equal to y to the minus 2, right? So, or 1 over y squared. This is the final answer, which is 1 over 2x plus 1 plus c e to the minus 2x. C is constant. Okay, and this is the way to solve the binary equation, which is make assumption v and y to the minus n and plug in, then use the linear equation to solve the problem. Okay.